Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Students, in today's lecture, we are going to discuss and solve the numerical problems of the chapter number 4. And definitely this is going to be the last lecture of the chapter number 4. And after that, there will be a test of the chapter number 4 in the coming week. So let's start with the numerical problem number 4.1. According to the statement, find the resultant of the following forces: 10 Newton along the x-axis, 6 Newton along the y-axis, and 4 Newton along the negative x-axis. So the resultant of these three forces we have to find out. For this, first of all, we have to write the data. So here is the data. The three forces are given. Force number 1, that is 10 Newton along x-axis. Force number 2, 6 Newton along y-axis, and force number 3, 4 Newton along the negative x-axis. The method to solve this numerical problem I'm going to use is the head-to-tail rule. Students, you know that in the head-to-tail rule, we draw the vectors in a way that we take the first vector and draw the second vector with the tail of the second vector is going to be joined with the head of the first, and moving on in this way we can draw a lot of vectors. And to get the resultant, we have to draw a line that is representing and joining the tail of the first vector to the head of the last. To solve this, first of all, we have to select the scale. So I'm going to write a scale here. For these vectors, I'm going to take 1 Newton equals 1 centimeter scale. You can take any of the scale, like you can equalize 2 Newton to 1 centimeter also, but here I'm going to take 1 Newton equals 1 centimeter for the convenience. And for representing the 10 Newton line, definitely I have to draw the 10 centimeter. 6 Newton force representation, I have to draw 6 centimeter line, and to represent a 4 Newton force, I have to draw 4 centimeter line. So this is our scale. And now we have to draw the reference, and this is going to be the reference here. There is the x-axis, and in this direction, in the left side, this is going to be the negative x-axis. And above, this is going to be the y, and that is the negative y-axis. So first of all, we have to draw a 10 centimeter line in the direction of the x-axis. So definitely I have to draw the line in this direction, and the length of the line should be 10 centimeter. Here I'm going to draw the 10 centimeter line to represent the 10 Newton force. So this is going to be the 10 centimeter line, and this 10 centimeter line is representing force number 1, that is 10 Newton. So here 10 centimeter is representing 10 Newton force. I'm going to draw the head here. So this is going to be the vector representing 10 Newton force. Now I have to draw the second vector that is of 6 centimeter length according to the scale, and this is going to be drawn in a way that the tail of the second vector is going to join the head of the first. So I have to draw the vector on the head of the first vector. So 6 centimeter line is going to be drawn in the y-axis. So y-axis in the vertical position. So we have to draw the straight line, and to get the straight line, I'm going to use a protractor here. So first of all, you have to take the protractor and mark the 90 angle, and in this direction you have to draw 6 centimeter line to represent 6 Newton force. So I'm going to draw the 6 centimeter line here. So this is the 6 centimeter line, and according to the head to tail rule, I have joined the two vectors. Number 1, 10 Newton, and the number 2 is the 6 Newton, and this is going to be the force number 2. This is 6 centimeter in length. Now I have to draw the line 4 Newton along the negative x-axis. So negative x-axis in the left side, so I have to draw here 4 centimeter line again, but it should be straight, and to get the straight line I'm going to take the help again from the protractor. So I have to draw 4 centimeter line in this direction. So in order to draw the 4 centimeter line, here in this direction, and I have to draw the line on the head of the second vector. So this is going to be the 4 centimeter line. So that is the 4 centimeter line that is representing the force Newton, 4 Newton force. So this is the force number 3, 4 centimeter. So in order to get the resultant, I have to join the tail of the first vector to the head of the last vector, and here the last vector is the vector number 3. So I have to join the tail of the first vector to the head of the last. So here this is going to be the resultant, and from the scale you can see that the length of this resultant vector is 8.5 centimeter. So here the resultant is 8.5 centimeter. So that's how we have got the resultant of these three forces by using the head to tail rule. According to the scale, 8.5 centimeter definitely is going to represent 8.5 Newton. So it means that our resultant force is 8.5 Newton. But to get the direction, we have to measure this angle also, and we have to measure the angle with the help of the protractor. Place the protractor on that point, and you can see that this is marking the 4, 10, 20, 30, 40, and this is 45 degree angle. So our resultant is going to be the 8.5 Newton force, making angle of 45 degree with along the x-axis, so x-axis. So this is the resultant, means the answer of the addition of the three forces. Let's move to the numerical problem number 2, where is the statement: find the perpendicular components of the force of 50 Newton making an angle of 30 degree with x-axis. So write down the data first. According to the data, what values are given? The force is 50 Newton, and that is making an angle of 30 degree with the x-axis. So this is going to be considered as angle theta. As you know that whenever the force makes an angle, this is considered as the angle theta. So we have to find out the component of the force. So the perpendicular components of the force is going to be the Fy and Fx components. So we have the formula, and with the help of the formula we can find out these two components of the force. So first of all, for the x component, means the horizontal component, we can use the formula F cos theta. So the force value of the force is 50, and cos of theta here is 30 degree. You have to take the cos of 30 and multiply with the 50, we will get the horizontal component. And for the vertical component Fy, we are going to use the formula F sine theta. The value of the force is 50, and we have to take the sine of theta, means 30. Again here, take the sine of 30 and multiply with the 50, we will get the answer of the y component. So with the help of the calculator we can take these values. So press the button of the cos, and then 30, the cos 30 is 8.66, and you have to multiply it with 50, and you will get the answer 43.3 Newton. That is the x component. And for the y component, we have to take the sine of 30. So here, press the button of sine 30, and you will get the answer 0.5, and multiply it with the 50, you will get the answer 25 Newton. So this is the y component, and this is the x component of the force. In the numerical problem number 3, find the magnitude and direction of the force if its x component is 12 Newton and y component is. So according to the statement of the third numerical, we have to find out the force from the components. So here is the data. The x component is given 12 Newton, the y component of the force is given 5 Newton. We have to find out the force and its direction. In order to get the force, we are going to use the formula, that is fx square plus fy square under root. So put the value of these two, 12 square plus 5 square, and take the under root. So here 144 plus 25, add these two values, and then take the under root. So the answer is going to come 13 Newton. This is the force. In order to get the direction of the force, we are going to use the formula theta equals tangent inverse Fy over Fx. We have to take the tangent inverse of the value we will get from dividing Fy means 5 over Fx means 12. So divide these two values and take the reverse tangent of these two values. So 5 divided by 12, we will get 0. Tangent inverse of 0.4166. So take the tangent inverse, how shift button of the tangent and 0.466. The answer will be 24.9 degree. So the force from these two components becomes force of 13 Newton, making an angle of 24.9 degree. By rounding off, you can also write it as 25 degree. According to numerical number 4, a force of 100 Newton is applied perpendicularly on the spanner at the distance of 10 centimeter and find out the torque. Students, here is the data, the force of 100 Newton that is being applied on the spanner. So here is the force 100 Newton and the force that is being applied at the distance of 10 centimeter. This is going to be the momentum. It is represented with L. So we have to convert it into meters first by dividing it with 100, and now by applying the formula of the torque, F into L, we can get easily the torque that is going to be produced with 100 Newton force. The answer will be 10 Newton meter. Now move to the statement of the question number 5. A force is acting on the body making an angle of 30 degree with the horizontal. It means this says the horizontal component of the force, which is Fx. The horizontal component of the force is 20 Newton and the value of this component is also given, that is 20 Newton. We have to find out the force. So here is the data. The x component, being the horizontal component, is 20 Newton and this component is making angle of 30 degree with the x-axis. So we have to find out the force. So we are going to use the formula of the horizontal component, that is Fx equals F cos theta. Here the value is 20 and force we have to find out, and cos of theta means cos of 30. Put the value of the cos 30 and then move it to the other side, we will get the force. So here the cos of 30, this is cos 30, the value is 0.866 and here is 20. So to get the force, divide 0.886 with the 20 because it here the multiplying and we have to move it, and this is going to be divided on the other side. So the answer will be, the answer is 23.09 Newton, and rounding off this value we get the answer 23.1 Newton. This is the force. Question number 6 is the steering of the car has radius 60 centimeter. Find the torque produced by the couple of 50 Newton. On the steering wheel, students, you know that we have to apply it on both the side the force, and the couple is going to make by the two forces that are opposite in direction, and their line of action is different. According to the data, the force is 50 Newton, so the same force is being applied on both the sides, so the force is 50 Newton and the direction of both the forces is different one, and the radius is the distance from the center of the steering wheel to the point where the force is being applied. This is 16 centimeter. So according to the meters, we have to divide it with 100 and the answer will be 0.16 meter. This is going to be taken as OA. As you know that for the couple, we have to take the distance between the 2 points where the forces are being applied means AB, and this will be the diameter. So we have to double the radius in order to get the diameter. So the diameter is going to be here 0.16 plus 0.16, and that is going to be 0.32 meters. So now we can apply the formula for the couple, and the couple is going to be the force into AB means the diameter. Force is 50 and the diameter is 0.32. Answer will be 16 Newton meter. Question number 7. A picture frame is hanging by the two vertical strings. The tension in the string is 3.8 and 4.4 Newton respectively. We have to find out the weight of the picture. So for this we have to see the diagram. So students, this is the diagram. That is the frame, and this frame is being hanged with two strings having tension T1 and T2. Means the forces that is being applied with the help of these two strings in opposite to the weight is number 1 3.8 Newton and number 2 is 4.4 Newton. Sum of these two tensions is going to be equal to the weight of the frame that is acting vertically downward. So we have to add tension number 1 plus tension number 2 that is acting upward, and the downward force is going to be equal with the weight of the body. So 3.8 plus 4.4 is going to be 8.2 Newton. So this is according to the first condition of the equilibrium, where the sum of all the forces is going to be 0, and the forces on one side is going to equalize the forces on the other side. Now for the numerical number 8, look at the diagram. Two blocks of the mass 5 kg and 3 kg are suspended with the two strings as shown in the figure. Find out the tension in the string. So students, here you can see that there are two strings. At this part of the string, two weights are acting, means the weight of the 5 kg mass and the weight of the 3 kg mass. Both these masses are acting and applying the force downward on this part of the string. But this part of the string, only the weight of 3 kg mass is being acting. So the sum of these two weights is going to be the force of the weight that is acting on the string, and the tension in the string is equal to the sum of these two weights. And here in this part of the string, only the weight that is 3 kg mass is going to apply the tension. So here we can solve it on the book. Like 5 kg is going to represent the Newton. If you multiply it with the 10, that is will give you 50 Newton. So 50 Newton, and here is the 30 Newton force. So sum of these two forces, 50 plus 30, is going to be 80 Newton, and the tension in this part of the string is 80 Newton. And this part of the string, the tension is going to be only 30 Newton. So we don't need to write on the board. So by the diagram we can solve it easily, but you have to solve it on the paper. Here you can see, according to the data, mass 1 is 5 kg, mass and its weight is going to be 50 Newton by multiplying it with 10, because g is going to be 10. Mass is 3 kg and the weight is going to be 30 Newton. So tension 1, that is equal to the sum of the two weights, and that is 80 Newton, and the tension is only equal to the weight 2, that is 30 Newton. In the statement of the question number 9, a nut has been tightened by the force of the 200 Newton using 10 centimeter long spanner. What length of the spanner is required to lose the same nut of 150 Newton force? Now here the two forces are given. One is 200 Newton, that is applying at 10 centimeter. So this is going to be definitely producing the torque, and we have to produce the same torque in order to lose the nut. So the force is now is 150. The force has reduced. So now we have to increase the moment arm, means length, in order to produce the same force or the same torque. So this is the data. Force number 1 is 200 Newton, and the length number 1 where the force being applied is 10 centimeter, and according to the meters, this is 0.1 meter by dividing it with the 100. And force number 2 is 150 Newton, and length where we have to apply this force in order to lose the nut, we have to find out. So accordingly, the force number 1 and length number 1 that is producing clockwise torque should be equal to the force number 2 and the length number 2 that is producing anti-clockwise torque. So clockwise torque and anti-clockwise torque, one torque that is tightening the nut and the other torque that is going to lose the nut should be equal. So force number 1 is 200, and here is 0.1. The force number 2 is 150, and length we have to find out. So length, we have to move this 150 to this side, and by dividing it we can get the value of 0.133 meters, and in the centimeters we have to multiply with the 100, so we will get 13.3 centimeters. This answer will be in the meter, and multiplying it with 100 we will get 13.3 centimeter answer. In the statement of the last numerical, a block of mass 10 kg is suspended at the distance of 20 centimeter from the center of the uniform bar 1 meter long. What force is required to balance it at the center of the gravity by applying the force at the other end of the bar? According to this, there is 1 centimeter length of the bar, and you have to balance it from the center, and one of the side the force is being applied, on the other side what force have to be applied. This is what we have to find out. Look at the diagram, students. This is 1 meter length of the bar. This is equal to the 100 centimeter also, and we have to balance this on the wedge, and this should be in the center. So middle point is the 50 centimeter. So there is a mass of the 10 kg. In the newtons, or in the force, we can write it as 100 newton, and this is 20 centimeter from the center. It means momentum here is 20 centimeter. And in the statement that is given that the force should be applied at the end of the bar, it means that the distance of the force should be 50 centimeter. We have to find out the force, how much force we have to apply here so that we can balance it on the wedge. So here the data, you can see the force 1 is 100 newton, force number 2 has to be find out, length number 1 is 20 centimeter, and length number 2 is 50 centimeter. So we are going to use the same formula. The anti-clockwise torque is equal to the clockwise torque. So here this is going to be produce the anti-clockwise torque, and this force is going to produce the clockwise torque. So force number 2 multiplied by the length number 2 must be equal to the force number 1 and length number 1. So force number 2 is here, we have to find out, and the length number 2. I'm not going to use convert the centimeter into meters. You can convert it, or you can leave it as such, because on both the sides the centimeters are being used. So if you want to convert it, we can write it 0.2 meter and 0.5 meter. So 0.25 meter is the distance, and force number 1 is 10, and the distance number 1 is 0.2. So here the force number 2 will be equal to the 10 into 0.2 divided by 0.5 by moving it to the other side. So if you divide it, we will get the answer of the force, that is you have to apply on this side in order to produce the same torque in opposite to the torque that is the clockwise. So the force answer is, so here is the 100 Newton force. So when you multiply the 100 with 0.2 and divide by 0.5, you will get the answer 40 Newton. So this is the answer of the last question. So now we have completed the numericals of the chapter number 2. This is the end of chapter number chapter number 4. So this is the end of the chapter number 4. You have to learn the entire chapter along with the numericals, and definitely I'm going to take the test of this chapter in the coming weeks. Thank you very much. Allah Hafiz.